Hey, what's going on, everybody? What's going on? All right, y'all, we're going to get this thing started. Everybody grab a seat, grab some pizza. If there's any pizza left, it looks like we've been killing it. All right. All right. Joe, just out of curiosity, show of hands. I know we have like a wide different array of crowd today. How many of y'all is this your first time coming out to Dallas Software Developer Group meetup? All right. So maybe about like 20%. That means about 80% you've been here before. Thank you for coming back. For those that are here for the first time, what took you so long? No. My name is Danny Thompson. If you're not familiar with who I am, I'm one of the lead organizers for DSD, Dallas Software Developers Group. We are a volunteer-ran and organized group right here. Everything that we do, we don't monetize in any way, shape, or form. We just do it strictly for the sake of the community. And so I want to give a shout out to a couple people in particular that helped put in the effort to make this thing happen. Big kudos and shout out to my brother over there, Eric Anderson. Eric. Big shout out to my brother, Dennis Garcia over here. Dennis. I'm just noticing y'all were pretty quiet when I introduced myself, but I'm just saying. I saw Clint earlier. Clint Anderson is somewhere. There's a Clint over there. Yeah. And huge shout outs to Braden Coyer and Devin Coyer. Both can't be here tonight, unfortunately, because they live too far. But huge shout out to them. They're doing a lot of effort. So we have a couple housekeeping items. Number one housekeeping item. How many of y'all in here are familiar with what this is behind me? All right, we got some education to do real fast. So one of the things that we do outside of all the meetups and workshops and community events that we do, one thing that we started doing last year is the Commit Your Code conference. This conference is very different, in my opinion, than the average tech conference that you've probably ever heard of, seen, or been to. As far as I know, I don't know any conference that does what we do. I'd love to be educated if there is one, so that way we can kind of show some love to them as well. Our big goal is to make sure that education and resources are available to everyone. So for us, I know during the pandemic, a lot of organizations, they slashed their education budget. A lot of developers working at some of these enterprise companies haven't been to a conference in years because of it. So for us, Commit Your Code, this year, we will have well over 100 speakers, which for real. Tickets start at $49. Your meals are covered for both days. Last year, we trended globally for our food. I'm just saying, social media has they were crazy about it. And the biggest kicker is 100% of all ticket sales are donated to charity. We do not keep a single penny. And we publish all of our financial data publicly, so that way everyone knows exactly where the money is going. We don't hide anything. We're very transparent about it. Last year, we even published publicly our financial postmortem, so everyone saw exactly what we ordered, how we did it, and where we got it from. We just like to be very transparent in that matter. Tickets went on sale for Commit Your Code on Friday. As of right now, we have sold 250 tickets. So to give you an idea, last year we had almost 400 attendees. So within 4 days, we have well exceeded 60% of the attendance from last year. So the reason why I'm emphasizing this now, especially to people in the room, please try and get a ticket if you want to attend earlier and sooner rather than later. The big reason why is this venue is where we host the conference. We host it down over there. And there's a cap on the attendance. So it's probably gonna be capped around 900. We will not be able to exceed that. And so with y'all being in here, it means you live in the Dallas area. It's gonna hurt my heart if you're like, I live here and I can't attend because I didn't get a ticket. And our refund policy is, it could be the day of. We're not here to hold your money hostage. If you buy a ticket and you can't attend, we don't want y'all to lose out on the money unless you just want to give it to charity. But you can easily get a refund. So please pick up that ticket earlier rather than later. I think you're gonna really regret it if you don't. I'm hoping that we trend globally again for this one. But we're doing a lot of things. We're emphasizing a lot more on the networking side of things. We're gonna have a lot of talks, obviously. But we have a lot planned for you to make valuable connections, whether you're at the highest levels of your career to the lowest levels. We've invited some pretty incredible individuals. Of the speaker list already that we've announced, we have 30 more that we haven't announced yet publicly. We will soon. We have CTOs coming. We have vice presidents coming. We have directors. We have you name it, the gambit is there. We have some that work at household name organizations, and we have some that you probably never heard of, but their technical ability is next level. And so we're covering several subjects: JavaScript, Java, cloud, and .NET. We have a lot of AI talks, but we have a lot of core technology talks as well. And we are doing a leadership track. So if you're like a senior developer and you're like, I don't know how to get to engineering managers, or maybe you're an engineering manager, I don't know how to get to a director level, these are going to be the kind of talks where you can kind of get the insight that you need. Those talks, my agreement with those leaders is those talks will not be recorded. So it would only be for the ones that are in that room to kind of benefit from those talks. For those that are online, we stream the entire thing completely for free. We don't hide any of those technical talks. You have an option to donate to charity if you want to, if you deem so. Like even if it's $5, I think it goes a long way. The 3 charities that we're actually donating to, I actually have it here now that I realized. I forgot we had this up here. The 3 charities that we're donating to, you can see here: Free Code Camp, St. Jude's Children's Church, and Operation Kindness. Operation Kindness, it was, we let the community vote on this one, and that was the one that they wanted. Phenomenal charity and organization, a lot of what they do. You can see here, the website, by the way, huge kudos. I think it looks phenomenal. We also have a host hotel. They're giving a pretty hefty discount to everybody. We don't get a kickback from it. If we did, we'd have to disclose it because the whole financial transparency thing. We do not get a kickback. We just let them extend the discount to y'all in that way. We have a couple sponsors for sure. But then you can see the entire speaker lineup. So some of the people that we have here: Aaron Francis, who killed it last year. We have Josh Long, Dan Vega, if you're familiar with Java. We have Swizzix, and I'll kind of go through the whole list here so you can see. We have some pretty incredible human beings. Some of them, I think a couple in the room. But we have Sarisha, she's CTO of Ad Media. We have Nicholas Perez, he's coming all the way from California for that one. So huge kudos there. Just some really great individuals that I think a lot of people can kind of get value from. Oh, we got this guy right here. But phenomenal speakers all around. Highly recommend checking that out. One other conference I want to give a shout out to, because a community member, he does it. Right there, Travis, if you want to talk to him, you can. He has DevOps days that he does around similar time. I think it's before. He's going to give us several tickets that we can kind of give away. So if you're interested in attending that, please let us know. I'll shout it out in the Discord as well. And if you are in this room and you are not in the Discord, I highly recommend fixing that. We have almost 13,000 developers in there from all over the world, but we have a private section for the Dallas residents as well, so that way you can make connections along the way as well. Now, with that being said, we need to do 2 shout outs. These are my last 2 housekeeping items. Number one, huge shout out for the building that we are in. They donate this space to us. They donate the space for us to do the conference. They really believe in the mission that we're doing. They're attached to this. And when a lot of companies say no, this is the company that always says yes, Yum Brands. Huge shout out to Yum Brands, please. Thank you. Now, this extra group, they deserve a huge shout out. Struck Development, sorry. Struck, they are an agency and tech consultancy. They solve a lot of problems. Same thing. When a lot of organizations, when it comes to sponsoring, so many of them say no because of what we do, they came through and they said yes. They're the reason why we have pizza in the building. They're the reason why we have drinks in the building. Please, huge shout out to them. Now, if you want to talk anything about Struct, Sean over there, Sean, you want to raise your hand? He will give you all the information you could ever need, want, and desire. But really, I would emphasize, I would hope, and I would really push y'all that if you ever find a need for Struct in your organization, contact them. You know, I'll say it once, I say it a million times. For us to do these events, most of the time we're paying out of pocket for everything. So whenever we get a great sponsor that wants to support the community, we love to have that. So huge shout outs to both of them. Last couple housekeeping items, mainly just treat everybody civil. Like, we're all grown-ups in here. Nobody needs to be foolish, and it goes with y'all online. Just be civil, connect. This is literally your community. Like, we exist to serve you in whatever way that we can. Feel safe here, feel comfortable here, have great conversations. I challenge y'all for one thing. If you could do this, we're going to have some great talks. You're going to get a lot of value out of it. I saw one thing happening in the beginning that I always see at these meetups. everyone often talks with the people that they already know, which is great. It would be incredible if you met someone new today that you didn't know and have a good conversation with them. So my challenge to you, especially if you already feel like you're uncomfortable talking to people, get a little uncomfortable in the next hour. Get out of your comfort zone, have a conversation, exchange the LinkedIn, exchange the Discord information, and just meet someone new, because that's what this community is. And if you're just so nervous that you don't know how to talk to them, tell them Danny told you to introduce yourself. That's all you got to do. I'll take the blame. I'll be the bad guy, okay? All right, y'all. We are going to start this off. Now, I'm going to be completely honest. I have not finished my talk. So I'm going to be in the back coding away so I can finish my talking time. Dennis over here is going to introduce all the speakers for me, but I will do this first introduction because he's taking care of things online. First speaker, one of my favorite individuals in the world. I'm so glad that he has supported us, 2.5 years coming back and forth. Patrick Hulce.
All right, everyone hear me in the back? Thank you. Well, thank you for coming. My name is Patrick. I am a machine learning architect at Netflix, but I am not here to talk to you about Netflix. I'm just going to talk to you about GenAI for media, talk about some image generation models, what we can do with them. My hope is to whet your palate a little bit, introduce you to a ton of different concepts that give you enough to maybe Google on your own, learn a little more about some of those. And we're going to dive deep on one in particular about fine-tuning image generation models for a concept or style that you like and something that you would like to generate images with. The original version of this talk that I tried was like an hour, and Danny would kill me if I was up here talking for an hour. I appreciate that I'm one of the favorite people, but I don't think it would have gotten through that. So I have cut out an enormous amount. We are down to sub 20 minutes, but we are going to be moving. Okay, so QR code, bit.ly link up here. I recommend doing that so you can follow along and take a look after the fact. To kick things off, though, I want to start about why I'm so excited about this. How did I come up with an hour's worth of content the first time? And that starts a few years ago with me writing a children's book. This is The Great Lion Escape. It's a story about my grandparents' escape from the Soviet Union during the Cold War. And that's a little heavy for a 3-year-old. So I wrote it as 2 lions escaping Boris the bear. And instead of climbing the Iron Curtain, they climb over the Iron Mountain. So just a fun little way to introduce an important part of my family heritage for the next generation. But it's not super engaging to read a book. You know what's even better? Making a book. So we're going to try and make a book here. We're going to try and make some illustrations and new images in the style of this book for the talk today. And to do that, we need to build a SaaS, storybook as a service. I'm sure that's what everyone thought when they saw SaaS up here. Rug pull completed. We can dive into the agenda a little bit. Oops. So first, we're just going to go over image generation basics. History, where did we come from? Where have we been? Where are we going? What tools are available today? And then we'll talk about a little bit about how they actually work. Then we'll get into the fun part. How do we actually customize them? What techniques are available to tweak these models to make them your own? And then we'll dive into the SaaS part, where we actually train and deploy one of these live, and hopefully we'll have time for a live demo. So image generation basics. What are we talking about here? Where did they come from? Well, we've actually been doing image generation for a while, and it's gotten really good lately, but it's been a long journey. And I kind of mark the beginning of this journey as 2014. Some would argue with that. But that's the year that I think most people in this space started thinking like, hey, we can generate some actually good images here. Like these almost look like a photograph. And it started with something called GANs, which are generative adversarial networks. If you've ever been to thispersondoesnotexist.com, you can try it yourself. You'll be greeted with a big face, and it's not a real person. It's just a face generated by an image model. And these are all based on GANs, and they're quite good. They look very realistic. They're hard to tell from a regular photograph, but they're very limited, right? This model was trained just for faces. There's no text prompts. You don't even get the rest of the body, no hands, right? Very limited in scope and what they can do. And so then in 2020, diffusion came along, a new technique for generating images, and nothing really changed yet. Everyone was kind of distracted by COVID and crypto hype and everything else that was going on, but the ground was moving. And with a innovation about a year later called diffusion, involved in some models that you may have heard of, like DALL-E or Midjourney or Stable Diffusion. We actually got something really useful and usable. And the ecosystem absolutely exploded with something called Stable Diffusion, which was an open source implementation of this entire thing that let you type in any prompt imaginable and get a half decent picture of whatever you could think of. So we've had a lot of iterations since then, some new versions. It's gotten better, it's gotten faster, it's gotten more accurate. And this entire collection is diffusion models, and this is what we're going to be talking about today. Now, this thing on the far right behind me is something that happened about 2 months ago when OpenAI came out with a new version of their image generation model that replaced DALL-E. This is actually not diffusion-based and not what we're going to talk about today. And I mean, you're saying, oh, Patrick, what you're talking about is so last year. Why are we not covering this latest and greatest stuff? Well, short answer is ecosystem. Diffusion has been around for a long time in the AI sense of the word. And we have a really mature ecosystem now in terms of plenty of tooling available, lots of examples, lots of documentation. It's much, much, much easier to get started in this with diffusion than the latest and greatest next generation of OpenAI models. Also, huge bonus, you don't need an $80,000 GPU to do what we're going to do today. So pretty much everything you can do with diffusion models can be accomplished even on your laptop. We're going to go through an example of still using cloud services that you can do it for pretty on the cheap, but a lot of these things can also be done. There's been a lot of community investment in actually making this very accessible and open. Before we dive into how to do that, though, and take advantage of all this stuff, we need to know a little bit about how diffusion actually works. So we're going to start with an analogy. Imagine you have a picture, really degraded, scratches, noise, stains, and we want to restore it to its original glory, right? We want to recover the original photograph here. Imagine we could isolate just the scratches, like just the stains, just the broken parts, everything that's not supposed to be there. If we had a magic wand that could do this, then we could subtract everything and get the original. So this is exactly what diffusion models are doing. They're taking a very obscured version of an image and slowly removing what's not supposed to be there to get the original, where the original is a new image we've actually never seen before. To make it a concrete example, we're going to walk through something called the MNIST dataset. So this is a really popular dataset in computer vision where it's just handwritten digits from 0 through 9. And we're going to try and walk through a diffusion model that is trying to give you an image of a handwritten digit given its number. So at the very top, we start with the ultimate obscured image, total random data. It's just random noise. There's nothing to it. And we're going to take this total randomness, and we're going to pass that into our model along with the number that the eventual image is supposed to look like. And we're going to have the model predict everything that's not supposed to be there. So everything that's not the digit that we passed in. And then we're going to remove just a little bit of it. And then we're going to do that again and again and again and again, 20, 50, 100 times, slowly from top to bottom. We get a little bit clearer, a little less fuzzy, until finally we end up with something that looks like a digit at the very end. Okay, so if you think back to our photo analogy, we kind of started in the middle of this process, right? Like we already saw some people, some shapes. It was just pretty degraded. And diffusion is just taking this to the extreme. We start with absolutely nothing, no signal at all, just random data. And our goal for the rest of the talk is going to be trying to guide this process so that we can introduce new concepts to how it decides to remove the noise. So how do we actually exert that influence? How are we going to tweak what the model is doing? Well, before we dive into the specific method, I need to cover some really basic ML 101. So I just want to gauge for my explanation here, a quick show of hands, how many people would be comfortable explaining to everyone else in the room what a model, training, and inference are? Like those three terms. Just like raise your hand if you'd be comfortable explaining that. Great. This slide is for you then. I came prepared, so don't panic. We're going to speed through the basics of machine learning. If you want to know more though, there's a bit.ly link down here where I gave a much longer talk on exactly this topic about a year ago. So if you want to learn more about these, please feel free to visit that after the fact. For now though, I need you to know those three terms: model, training, and inference. So we're going to walk through them. First is model. I've used that a few times already. The only thing I want you to take away from a model is that a model is some description of how to transform some data, and it uses a bunch of numbers. Okay. Some description of how to transform some data, and it uses a bunch of numbers. Okay. You can call it a function, a recipe, a formula, whatever you'd like to do. But it transforms some data, and it uses a ton of numbers. And we call those numbers parameters or weights. So the model is how to do it plus a bunch of numbers. And we're talking a lot of numbers. So in these diffusion models, there are billions of numbers that are used to turn text into images. In LLMs, they can even get to trillions of numbers. So there's a lot of numbers. And if we have so many numbers, how do we come up with them? How do we know what they are? Well, we don't hire a ton of people and have them guess like, well, 5,873,503 is 2.5. It's not how it works. We are going to have engineers automate this with some data, and that's what training is. So training is the process of deriving a model's parameters, given its description of how to transform it and a bunch of data about it. Okay? So training is just the process of computing those weights or parameters. And then finally, we have inference, which is actually doing something useful and using the model on data we haven't seen before to predict something. So it's actually applying the procedure with the parameters that training computed. Okay. So if that's still a little fuzzy, this is 101. Hit that bit.ly link up. And I just want you to hang on to the fact that model has weights, training computes the weights, inference uses the weights. And in the context of image generation, we're working with a text to image problem, which means we want to take some text and convert it into an image. So our model is transforming text into an image, which means training needs lots of examples of images with their corresponding text. And training is going to give us the billions of parameters that we are supposed to use. Okay, so that hopefully in the end, we can do inference and say something like a dog and a cat and get both of them in the same picture, even though our training didn't necessarily have an exact version of that picture. And now, thankfully, someone else other than us has spent millions and millions of dollars to get those billions of parameters for a large number of topics that we don't have to worry about. So we're going to stand on the shoulders of giants today and just try and tweak a little bit of it to introduce a little bit of our own, but mostly rely on the fact that someone else has gathered billions of photos and spent tons of time doing the training part mostly for us. And we're going to do that with a technique called LoRA. So this is super clever. This is basically training part of a model rather than the entire thing at once. So we're going to take something that is mostly trained, and we're just going to say, well, if you want to generate a bunch of photos of Master Chief from Halo, you don't really need to touch how the model does cats and dogs and ancient Egyptian pharaohs, right? You just kind of need to tweak human sci-fi soldier a little bit. So we're going to build on the fact that someone else has trained a model that seen a lot of different objects and already knows about a lot of different things. And we're going to just try and introduce one new concept or one new style and associate it with a new word that we pick, right? And we can do this with just like 10 to 100 examples instead of the millions or even billions of examples that require a full model training. So we're going to do this using some Python libraries. And in practice, it looks a little something like this. So pretty much the same process at a high level that we were doing for the full model training. But if we wanted to do it on like a specific pet, you'll notice there's some nonsense up here, which is the first step of your lore, which is picking a trigger word. And in this case, I've picked a Zuxful, because hopefully that's not a word or something that exists in the model's memory somewhere. And this real dog's name is Bentley. And if I picked Bentley, we'd get cars mixed with dogs all over the place. So we don't want to pick something that the model already knows about. You'll also notice that I include the word dog too, right? This is part of that magic. The model's already seen tons of images of dogs. It basically already knows what a dog is. We don't need to teach it what a dog is. We need to teach it this specific dog looks kind of like this. And so that's what LoRA's going to do. So instead of millions and billions of photos that are labeled, we're going to give it like a dozen to maybe 100. And instead of getting billions of parameters, we're just going to get like a few million that we need to edit. And then with that, we'll be able to basically patch up our old model, and then we'll get the combined power of both. We'll be able to say, my Zooxful dog with a cat and everything else that the model knows about already. So that's the goal. Okay, almost there. Practical part. How do we actually do this? How do we actually build our storybook as a service? Well, there's tons of different ways you could go about doing this. I jumped at the chance for this talk to try a new vendor that I was excited to try out. It'll hopefully make this much easier for you. And that's enter Modal. Hashtag not a sponsor, although Modal, if you're watching this, DMs are open, come try it. But anyway, they made this work really easy. It's, think, a cloud provider alternative to AWS, GCP, Azure, and they make working with Python and ML jobs and AI training much, much easier. They let you deploy backend jobs, APIs, all kinds of stuff. My favorite thing is doing this per second GPU billing for inference. As soon as it's done, it just shuts down. You don't have to spin up an AMI over and over again. Hard billing limits, which for people that aren't giant companies is amazing. I do not have to worry that you guys are going to bankrupt me hitting my demo after this. It'll just shut down when I run out of money. Huge GPUs. If you know a little bit about this, they have H100s and A100s just on demand whenever you want them. And a generous free tier. I was able to do everything for this demo and host the demo completely within the free tier without paying anything. So pretty great. I hope you're sold. If not, maybe how easy it is to use might be worth a try. Getting started is super straightforward. For this, I'm going to assume that you have Python installed. So if you don't, come talk to me later. That's like a different talk to have about setting up Python. But assuming you have Python installed, you're going to pip install Modal. And then you're going to do Modal setup, which basically links your Modal account to your Python environment. We're going to cheat and download the whole LoRa training script that I've already prepared for you. The handy dandy personalized link. And then we need our training data. So for this example, I'm just going to grab some example photos, but you can pick yourself, a relative, a pet, your favorite character from a TV show, whatever you'd like to try this out personally. Now, that would actually get you all the way there, but I do want to walk through some pieces of this massive LoRa file so that you learn something about what it's doing behind the scenes. So first, we're just need to set up the basics of our environment. For Modal, this is basically our Python dependencies, our system dependencies, and a Docker image. And then we need to get some persistent storage to store the result of our model at the end. So that's the bottom here. And then we need our training function. So this is super generic. You'll see it says name of training library. I don't want you to focus on what the name of the library is. I just want you to walk away with the main concepts of what are the inputs and outputs of training, right? So we need to connect up the fact that we're using our image that we defined for Modal. We have our persistent disk where we're going to save everything in the end with just saying GPU equals A100 80 gigabytes. We get an A100 with 80 gigabytes of VRAM. This is way overkill. You don't actually need this, but it's so freaking cool that you can do this in like 5 seconds for free that had to include it in this example. And then we basically launch our training with our inputs, which is our trigger word made up, our training data, our URLs to our images, and then that class that we're piggyback offing. Right? Remember, this is how we're kind of bootstrapping everything. We're leveraging the fact that the model already knows what this type of stuff is. Then we say what model we're fine-tuning, and then where we want to spit out everything when we're done. When that's done, we basically say commit that modal, which means it's going to upload that onto our persistent disk for using it. But that's just training, right? So we run this, modal's going to spin up our container, attach the A100, do the training, spit it onto the persistent disk, and then shut down. It cost about like 60 cents. It's great. But we haven't done anything useful yet. All we have is like a billion numbers sitting on a persistent disk somewhere in the cloud. Anyone brave want to remember what is it called when we actually use the model? Yes. Inference. Thank you. Someone was listening during ML 101. Gold star. I didn't bring any prizes, but next time I will. You have my word. Exactly. So we need to run inference. So Modal has a solution for that too. And this time in our magic little Python function, we're going to return a fast API object. So if you're not familiar with Python, fast API is just a framework that lets you handle web requests really efficiently. It's similar to Express if you've worked in Node. Not quite as full-fledged or opinionated as Next, but sits somewhere in that kind of request handler layer. And we're going to spin up a diffusion pipeline from a library, load from our persistent disk, create our fast API, have an endpoint that runs that pipeline using the user's prompt, and then just return the image. And that's basically it. We're ready to rock. You just deploy it, and we have a live service. Does anyone want to try it out, like right now? Sometime? Yeah, we got some nods. All right, let's go for it. So this is the lovely example app. And we're going to just pick a lion leaping in the jungle. And I should have warmed it up before starting. So the fact that it shuts down is how you don't pay billing. So the cold start problem is there, but only a few seconds. It's honestly pretty amazing how they've gotten it down, even with all your custom dependencies. So we're going to click generate here, and you'll see that I have kind of a regular description along with, in this case, when I trained this LoRa, it was SKS storybook illustration. So what's happening here, right, is that entire diffusion process we looked at. So it's taking the billions and billions of parameters that we have in this model, and it's trying to take some random noise and say, what is everything that is not a lion leaping in the jungle in an illustration using that LoRa? And then it's doing it again and again and again and again and again, 50, 100 times, until we finally have removed everything that's not the prompt that we asked for. And normally it only takes 30 seconds. And that's all I prepared for while you were waiting for this. So if anyone has any great stories to cover the rest of the 20 seconds, let me know. Ah, there we go. There we go. Thank you. Live demos always work. That's great. Okay. To save us a little time though, for the next few, I pre-generated a couple just to compare like what is the LoRa difference here, since you obviously have not read my book. Was that even good? Who knows? Well, this is the original of a prompt that's basically, ferocious brown bear running in icy tundra. And if you do this without a LoRa, you get something like this, which is a fine illustration, but not exactly the style that we were hoping for. And with the LoRa, we get much, much closer in the kind of waviness, the style of the illustration, and much, much closer to what we were hoping for. And all of this was done with 10 completely random crops of the book. I could go much, much further, much more meticulous with my prompts, many more examples, and take this even further. But with 10 crops and 60 cents, you too can get this far with custom image generation models. But you don't have to take my word for it. Feel free to hit that demo. You can hit the bit.ly link, use the QR code. Again, it's capped billing, so have at it. First come, first serve, and then it's out. No sweat off my back. But deep breath, we made it. That was a marathon, a little over. But I always try and learn something from the audience myself. So I have a couple quick questions if we can do some hands. The first one is, how many people felt like this was a little bit too advanced, like they didn't know what terms were, or they got a little lost along the way? And if you don't feel comfortable going and training your LoRa, like right after this, your hand should be raised. Okay. All right. I appreciate your honesty. Thank you. All right. How many of you felt like this was too easy? Like you already knew all this stuff. This is old news. No one? Okay. All right. Sweet spot. Beautiful. Goldilocks zone. Finally, at these talks, I like to kind of gauge interest on hypothetical future talks. So if you had to hypothetically pick between 4 options here of ML inference, going like deep on how to make inference faster and more efficient, like distillation, TensorRT, things like that, that would be option A. Option B would be far more user-centric. How do you actually use GenAI tools like this to make videos and pictures and things that you actually want to make? C would be kind of like this, but a much more hands-on, more actual code, not name of training library here, but actual examples. And then D would be a meta talk, how to give a talk, depending on how well you think this went. So those are my 4 choices. You can vote for as many as you want, but only raise your hand if you would like cancel your plans and actually go. So who would show up for A? Okay, like 20%. All right, B. Okay, a little more. C. Okay, pretty sizable. D. Okay, all right. Well, thank you, everyone. That's all I got. I hope this gave you a little bit of inspiration and the confidence to go try out your own image models. And if I haven't gone way, way, way over time, happy to take any questions.
All right, I get another speaker next up here is Ben Perri, lead architect of Enterprise Holdings.
All right. Hey, guys. My name is Ben Perri. I'm a lead solution architect during the daytime and head of security for a small AI startup during the night and the weekends. So wearing two hats, one of corporate, everything is extra slow, heavy, hard to maneuver. The other side is suicidal. Let's make new feature, let's release, let's make new products every other day. So I kind of like I live in those two worlds and I get to experience both tags in those two different directions. And I can bring stuff between those two worlds and help to bridge them. So one of the big challenges around building products and creating applications is introductions of new features. How do you take your product, your vision, your ideation, and connect it to other ecosystems, other things, bring data in, take data out, allow people to take action with your app, allow your app to take actions on their behalf? How do you integrate what you are trying to build or what you already built into other ecosystems, using those other ecosystems as funnel for your app, as integration of customers, and as integration of way to consume what you're offering? I'm going to talk, what you see here is a flow from a vendor called N8N. N8N is a low-code, no-code automation workflow. What's unique about N8N and why I'm going to talk about that is the ability of integrating AI solutions inside your workflows. And why integrating AI in the workflow is matter. If you're creating an ETL process and you're trying to take data, manipulate it, modify it, push it to something else, you need to know what you're getting, you need to know what you're producing. If you don't know what's coming in, you don't know exactly what's going out, it is very hard to go ahead and sort, itemize, understand what you have, and take insights and actions on that. This is where AI is a powerhouse in that regard. It can take unstructured data, data that is fragmented, data that is not necessarily connected, get some logic out of that, run some type of a process of an insight or extraction, and get you some normalized data on the other side. So what you see here in that flow, and I'm going to talk about those specific components and how you can use them. So this flow is just one example out of many you can find outside in the internet. This flow is taking end-of-life data of different vendors. It have a list of websites of different vendors. It goes to those websites and it scrapes the information and it looks for specific vendors' products, software, hardware, and when each device or each software runs end of life. You don't know how many devices are in each web page. You don't know how the web page is going to be structured. You don't know what to expect in the data that you're going to see. So the idea behind this workflow is taking something that we don't know what it is, we can't anticipate how it's going to look, and then taking that to a format that is something that we know how it's structured, what we can do with that. And then in this case, we're actually going to create meeting invites and team notifications based on specific end-of-life dates to make sure nobody forgot to renew the contract, change the code, upgrade the hardware, you name it. So the magic is where those yellow arrows are in the picture. And you can see there is other blocks of AI models over there. I'm going to dive into those two, explain them as a concept, and show you how you can use that to whatever you are trying to automate, whatever new capability or features you are trying to test with your application. And you can see how you can connect things to your app and open the door to a whole new ecosystems of products, of other components that can now talk to your information. All right, so the first block you will see in the screen have a markdown. That's a name that I gave it. And basically, that's an OpenAI model within N8N. You can connect to any OpenAI model, different type of tools. You can go ahead and allow it access to different type of data. You can connect it to Google Docs, you can connect it to Office 365, you can connect it to your Gmail, you can connect it to your Postgres, you can connect it to your Mongo. Whatever you have, you can now connect the data into that model. In this example, you see that I have an MCP connected. N8N allows you to create different workflows, and you can create a workflow that is service another workflow, same way like you would create a function that is nested. So the MCP in this case is another workflow or another chunk of workflow where I actually have the model with all the information connected to that model. So if I want to reuse that component, I don't have to do it again and again and again. So just for efficiency. In this case, the MCP is connected to 4 different documents in Google Sheets in this case. This is showing an example for an environment that doesn't use any fancy data. They're only using Excel to manage all their environment. So I want to show that customer a way on how they can go ahead and look at the data, even when it's unstructured in Excel. So in this case, we are looking at the different sites that we want to scrape, like I mentioned, the device list, some other nodes. And this is where we're going to use that as a data store. That's again, a dirty example. I will not use Excel as a data store. I mentioned earlier that you can bring a lot of data in and you can take a lot of data out. This is just part of the tools that you can connect. And you can see you can connect to an S3, you can connect to a GCP BigQuery, you can connect to a Supabase, if you're using that Postgres that I mentioned, Pinecone, you name it. Any data source that is out there is available here. And if the data source is not here, or whatever you're trying to connect is not here, there is a really simple documentation on how you can create your own node to connect to any data source that you want. So if you build your app and it doesn't have WebSockets for you to call directly, or God forbid, you don't have a REST API or GraphQL, you can go ahead and build a node that goes and fetch the data or make some calls to bring stuff in or take some stuff out. So we talked about that block that I showed you earlier that have the agent that connect to that MCP. And in N8N, everything has an input, everything has an output. So you see the input of what the model gets on the left side. This is all the script information of all the website I was looking for. In this case, it's 4 different websites. This one, I think the first one is Big IP, F5. And then in the middle, you will see what the model is doing, how it's configured. I'm going to dive into that in a minute. And then the output is on the right side, and that's basically going to the next block on your flow. So in this example, you will see that all the stuff that is coming out comes as a single message. In one click, you can go ahead and add a breaker that takes that and break that to individual record, and maybe put a title in each one of them that you can use for your next line item. So manipulating the data that goes in, goes out is very, very easy. So how that magic of that AI model looks under the hood, it's really straightforward. You connect your OpenAI account in this case. I will show later they have other models as well, what type of resource, what type of operation, and the model that you're using. The system prompt and the user prompt is where the magic happens. You'll see in this example, I'm calling out very specifically what it should go ahead and look for in the web page. What type of information matters and why it matters. Not only that, I'm very declarative about what output is expected and telling it I want as a JSON because I need that for the rest of the workflow and I need the data structured. It's all about taking the unstructured, unknown to move it to something that is known as structured, and then I can work with that easy. So telling it what to expect, how it should do the output, give it some key conditions. For example, how the data is formatted. It was going crazy if I didn't give it to it. So sometimes you find that you need to give it some pinning around some parameters on what it needs to do. One of the functions that I'm doing in my process is around the dates. And in some cases, it didn't find end of life because end of life wasn't published. So, okay, if we don't have end of life, it's year 2525, and that when we know that's the date, but that's like a future placeholder so it doesn't break the other things down the line. The top part of that window is in this slideshow. You can see that we also look at data that we need to inject. The data that was on the left side, we need to inject into the prompt. That's what you see here in the user prompt. This is where I'm taking the scraped website, I'm taking the data that I had in the previous block, pushing it into that with the system prompt that I had earlier. And again, I'm telling it, hey, make sure to output that as a JSON because I want to use that. And on the bottom here, I don't know if it's really visible, you can see that it's showing that the MCP is connected to that component. This is another example on another process using the AI. This is a completely different prompt. This is where I'm actually taking that end of life and I'm starting to process that. I want to take a look at the products I have. I want to take a look at the products that it found for scraping. I want to match them, and then I want to see what matters for me. So again, I'm looking at a long list of things, and maybe the product on the vendor website is all capitalized or have hyphens inside the name, or maybe I had a typo when I entered my product name on my table for my current list. So again, using AI, it doesn't do character match. It's going to do intention match between those two. And even if there is a typo, it will be able to autocorrect that and match those two products. The block I used earlier is the OpenAI block that you see, the second one from the top. There are many options on different integrations that you can do. You can integrate LangChain, you can integrate basic LLM chain, you can do extractor, you can do sentiment analysis on the answers. You can do a lot of massaging on the information, on what you're getting in, what you're putting out. You can generate insights and values based on that. One example that I did with the sentiment analysis is looking at a generic email of a customer, info@abc.com, get different requests for different type of topics. We built a different RAG agent for each one of the personas under the business, HR, CTO, COO, all those different functions. Depending on the email, the subject, and the topic, it goes, it looks at the Gmail or the account that is taking all that email. It goes, it do analysis, it do sentiment. If the person is angry, we usually don't let the bot answer him. We let a human answer the angry person. But if the sentiment is okay and it's normalized, we'll let the bot answer that based on the content of the conversation. We're going to have a funnel that selects the right bot. I mentioned earlier that there is a bunch of different models that you can select. Here is a really long examples of what you have. And if you don't find what you need, if you guys don't know about OpenRouter, it's a good time to know about this service. OpenRouters allows you to use their service as a proxy for almost any LLM that you can find there. That is, it's a full pay-per-use. Of course, they're going to take another 20-25% on top of those credits. Everybody needs to make money, but you get access to everything. And you don't need to pay for different APIs in different places. One credit card in one place, and you can go ahead and use that. You can also use local Olama. You can run everything locally or run some things locally. It doesn't have to be all or nothing. You can go ahead and have one agent that is doing, let's say, a really small job, run a small 3 billion model that runs locally, and maybe the heavy lifting, you go and you send to the API and to other external services. I mentioned earlier that there is a lot of integration that you can do with other tools. One of the cool things is human in the loop. The biggest challenge I see with large customers, with enterprises, is lack of trust with AI and a lot of bias around what is expected, what do they think they should get out of that, what are the risks. There is a lot of pre-desires that they think this is, okay, how I'm supposed to address the AI, this is what I'm supposed to get, and when something doesn't address exactly their vision, people are getting scared of AI. Putting a person between an automated answer is one way to mitigate that risk. I mentioned that example earlier on the email with the CEO, CTO. In that example, the customer didn't want an automated response from the chatbot to the person. They didn't want anything to get blown, someone get triggered, maybe a wrong information is provided. The level of trust right now is very low. So what do? We introduce a man in the middle, We go ahead and we send them a message. In this case, we do a Discord message. They get a message, hey, the company got this email. You are the designated COO, for example. Your chatbot responded this to the customer. Do you approve or deny that message? If he clicks approve, it will go execute the flow. We'll send the email out. If he says no, then the email is going to go to that person's mailbox, and he's going to have to address that personally. So this is one way where you can introduce trust and make things easier by using those human in the loop and letting people control what is happening. Eventually, they're going to tell you, okay, I don't want to see those messages anymore. It's just noise. When you get that message, you know you won and your product is really good. So that's about that. I mentioned earlier that you can integrate with a lot of other ecosystems. MS Teams is one of the biggest one for large companies. I gave MS Team here is just as one example because there is a lot of things that you can do inside Teams. You can create a channel, you can create a message, you can do a DM, you can raise an approval, you can do so many things. And this is just Teams. Any one of those applications that you see on the left side have about the same amount of capabilities. Some are more, some are less. I mentioned earlier that you want or you should integrate what you're doing with your applications. If you have a webhook, you can go ahead and do a direct webhooks from those flows. It will go, it will collect, decide which type of token do you have, a bearer token, a header token. You can add that to the flow, it will go, and you can do whatever you need to do. You can do a direct HTTP request. And again, you can also build your own node that goes to your whatever API backend you have and you want to use. The one downside I will point out, if you're looking to run it with a node that you're creating, you cannot use N8N SaaS offering. N8N have a SaaS offering that basically runs everything in the cloud, but you can also run N8N locally. Running N8N locally is amazing. And the reason I like it so much, because large organizations, onboarding a new vendor is very, very challenging, especially if it's a SaaS. You need to look at the SOX compliance. There is a vendor risk management. There is a lot of red tape. But when you do stuff locally in your own blast radius and you have full control, things are much easier to sell. So again, lots of integration with different things. You can connect the ingress, the egress, and everything in between. So that's the flow again. If you want that JSON file, I'll share it with you. Hit me up on LinkedIn. This is the QR. Go to YouTube, go to Reddit. There is so many posts, so much information around creating those workflows, and you can find how you can supplement your application, test new concepts, connect the application to new ecosystems, show that it works, create a proof of value, and then it makes sense possibly to go build it in-house, embed it within your product, so you don't have those dependency on secondary products outside of your ecosystem. Thank you.
All right. David? We got David Ojo coming up here, software developer.
Hello. So this is probably a good talk to follow up after you. So my name is David. I'm a software developer, pretty basic. I've been working in the industry for about 4 years. Previously, I was a full stack developer focusing primarily on backend systems. At my previous organization, Division Maintenance Group, I worked there for about 3.5 years. And right now I just do consultancy for startups. So that's me. So today's talk, we're going to talk about building AI workflows, very similar to the talk that came before. But instead, we're going to talk about building these workflows with LangChain and LangGraph. So it's not a no-code solution. It's actually a lot of code solution, but I like the LangGraph framework as it's a low-level framework, but it just offers a lot of control on the type of agents and workflows that you can build. So this is the agenda for today's talk. We're just going to talk about why LangGraph, talk about some of the core APIs and the patterns that you can create using LangGraph. We're going to talk about structured output, as that's very important For a lot of these systems that you're building, you want some sort of structured output that you can act upon. We're going to talk about building a very simple graph, as well as introducing the LangGraph Studio, which their team likes to call it the Agent IDE. It's a web interface that's very useful for debugging and visualizing your graph workflows, as well as for tracing and observability. So you get more insight into what's happening under the hood for all of your LLM calls. And then finally, we're going to talk about two projects. So I have two MVV projects. They're proof of concepts to just go over the type of systems you can build utilizing LangGraph. So why LangGraph? So LangGraph is an orchestration framework. It doesn't directly tie into AI and LLMs. It was birthed out of the LangChain ecosystem. So LangChain came out in about October of 2022. It was developed by Harrison Chase when he was still working for Robust Technologies. And his motivation behind building LangChain is he wanted to create layers. He wanted to create layers of abstraction over operations you would use when building your LLM application. So you think of memory, you think of retrieval, either from a vector store or directly from a DB. You think of for RAG as well. That's very useful. So LangChain was meant to, as well as you think of having reusable wrappers over all of the model providers. So LangChain was birthed to sort of create a framework around building your LLM applications. They utilize this pattern runnable sequence, which you can just think of it as functions that are just piped one after the other. Now, naturally, as these AI systems that people try to build become more and more complex, there was a need for something different. In this case, it was LangGraph. So LangGraph was birthed out of the LangChain ecosystem. It was created January of 2024, and it's a graph framework. So the goal is to orchestrate, to build workflows as opposed to focusing on deterministic paths where one function is called, it pipes its result to the next function, it then pipes its result to the next function. Instead, we're focusing on building stateful graphs and then designing control flows on how we want to route between all of the different nodes within our system. So that's why LangGraph is great. It's not the only framework to do this. There's also Crew AI, there's Pydantic AI as well as I believe AutoGen. So there's a lot of examples in this space. It's still early on. So, I mean, I wouldn't tell you to bet all of your horses on LangGraph. There's a lot of, you don't know what might be the new best practices a year from now when it comes to building these LLM applications. But from just my experience from some production applications that I've deployed, as well as from example use case, I've had the most fun developing these applications with LangGraph. Okay, so now we're just going to go over briefly the LangTrap core, some of the APIs that they have available. So at the base of all LangGraph, at the base of all workflows, you want to think about state. In this context, state is just a key value store where we can add an optional reducer function to determine how we want to update our state. So these are the two patterns that you'll see a lot when diving deeper into LangGraph code. The first one, we have a message key, which is just a type base message. It's just an array. And what we decide is as we make new updates to our state, we want to concat every new entry to the previous value. Now, we don't need to do this. Ideally, we can just have a messages array and we can just append every new value. But this is just built so that if we have a node that needs to update more than one message to the state, this one function can handle that. And we also have another state key just called name, where it's just a string. And all we're doing is just replacing the previous value with the current value. So when we think of building our graphs, we first want to identify our state. Now, And also, all of these examples are in TypeScript. LangChain offers, it's available in both Python and in TypeScript. The reason why I went with TypeScript is there are no, there, there are no documentations online for your TypeScript applications. If you go online and look for examples, everything's in Python. So I thought that was a bit of a disservice that there isn't as many TypeScript examples. And even when you go to ChatGPT, it would hallucinate for me all the time, where it would just try to rewrite the Python library in TypeScript. And I'm like, it's not a one-to-one port. So I just wanted to force myself to just build as many of these applications as I could, just using the TypeScript library, just for fun. So this is a very simple node within our system. The best way to think about a node, it's a function that accepts two arguments. The first argument is the state. So this is the state that we use within our application, as well as the second argument is a runnable config. So while the state can be updated as we move through the system, the configuration are values that we set after we compile our graph and then invoke it. And that will make a bit more sense later on. But the config is very useful when we want to modify the behavior of our system. For example, if we're deploying a system that's supposed to be used by multiple vendors, we might want to set configuration values that changes the behavior depending on the vendor that is using the application. So this is a very basic graph. We can modify the state and we return. So our return from all of our nodes will just be a partial version of our state, because every node is just responsible for performing some action and then updating the state. So when you think of a graph, we have nodes, but those nodes need edges, right? We need to connect everything. So in LangGraph, you can think of three types of edges. There's a direct edge where I know that node A, after its execution, needs to go to node B. I predefine that in my code, it's there. There's the concept of a conditional edge. So depending on the state after the node has executed, I can decide to conditionally route to a bunch of different nodes. So this is useful, like for example, if you have a node that's meant to look at some data and then to update the state, whether or not that data is valid or not, a conditional edge from that node can check the state. If it is valid, if it's true, go proceed to the next node to review the results. If it's not valid, proceed to the node beforehand to retry creating the results. So this is very useful, but sometimes we don't know what our systems are. When developing these multi-agent systems, it is extremely dynamic. We don't know beforehand which is non-deterministic, which route our workflow needs to take. So for that, we can use these two APIs that are available from LangGraph, their command API as well as their send API. Command is very useful because when we are implementing or working with any human in the loop flows, at that point, we stop execution of our graph because we're waiting to receive some input back from the user. So using the command API, as well as a unique thread ID for that agent invocation, we can use command to resume our graph. So it's very useful for resuming from human in the loop flows, as well as for routing to specific nodes. So command is very useful. They offer two fields that you can use. So you can go to a specific command within your node. You can go to a specific node within your workflow. So without clearly defining, and it'll make more sense later on when I say without clearly defining your edge, you can have it so that a node can move to another node within the system just dynamically, as well as it can update the state as well. So within one command, you can progress to another node and update the state. So that is very useful. Send is also useful as well. Send, you'll see a lot of people use the send API when they are using like the map reduce pattern, where they have multiple things that need to happen in parallel. So the best example is performing deep research. If you have multiple sections of a research report that you need to generate, you don't need to wait for each report to generate one after the other. Instead, it would be, a lot more efficient and also not as long if you could generate all of the reports in parallel. So the send API is very useful when you need to perform these parallel tasks. So at the core of it, when you think of these chat systems, persistence should be in mind. For example, how, like, if I go to a chat bot and I say hello and it responds, and then I respond back with what was my last question, we need some persistence layer that can actually show us, yes, in this thread, this was the last message that you had. So LangGraph is perfect where they have a persistence layer built in. And it's really easy to integrate it within your application. So what happens is they have these checkpointers. So at every step of your graph, you can save the current state to a checkpoint. And for me, I like to use their Postgres saver, but they have a lot of different savers that you can use as well as they have a base serialization and deserialization interface. So if you wanted to create your own custom checkpointer to use within your system, you can. But the goal of this is with just a thread ID, you can implement and add this checkpointer to your graph so that you don't have to go in and write all of the glue code for fetching previous state. The easiest example is just for a chat history. As we saw before within our state annotation, we had a messages field, a messages key. So as we go through our graph, we can decide to append to this messages key. So let's say I then leave this chat and I come back to it a week later. Because we have this built-in persistence layer, and more exactly, because we're using the Postgres saver, as long as I invoke this graph with the same thread ID, without me having to write glue code to save the chat messages to a database and then fetch the chat messages to the database, then now interpolate the prompt message with that chat history so that the LLM can best make its response. It instead will automatically happens for me under the hood. So this is very, very great. And then we want to think about configuration. So when we define our configuration, it is a key value store, very similar to our state annotation. The difference is we don't update our configuration. So this is useful if you want a set of values or keys to change the behavior of your system. So in one of the examples I have later on, it'll show how we use configuration in order to modify how our agent operates without having to modify any of the code. So this is just a basic example of, configuration is one of the input arguments for any of our nodes. And then here we're just grabbing I don't know if you can see it, we're just grabbing the business name from the configuration. So this is how you would actually use it. This is in the code example. After you compile your graph, when you invoke your graph, you would want to pass this configuration object, which will then now be accessible to all of the nodes as well as all of the tools that you have available in your system. So this is very useful. So we're going to talk about structured output. Now, I love this very, very much. I remember like 2 years ago using the LangChain, like their base API, and then trying to have structured output, and it was a pain. You would make your call to OpenAI, and then you would need to have some dynamic way to create your format instructions, and then you would now JSON parse your response from OpenAI, and then you would also need to do a Zod safe parse on top of that, just to ensure that you have type safe data at the end that you can work with, as well as you need mechanisms for retries if you're unable to parse that data. Now, that was very tedious work. And I'm glad that the LangChain team has, they've created a very simple API, or I guess a very simple pattern you can use when trying to create structured data. So the way that it works is you just create your output schema. For here, I'm using Zod. We create our base LLM class. Now, the good thing is that all of the chat wrappers that LangChain provides, they all inherit from the same base class. So if I were to swap this out to Chat Olama or Chat DeepSeek or Chat Azure, everything below the code wouldn't change. So I create my LLM. I then create my structured LLM, which is just simple. Just I call the with structured output function, and I just add the output schema. This is just a very basic example of, I want an LLM that can generate SQL queries, and I need to ensure that the response is an object with the field query. So this is an example of how you would introduce structured output into your systems. And this is very useful because you can do a lot more with structured output rather than, you just get back text and then you have to call another LLM to reason about that text and decide to take a next step, rather than you have like an object that you can just either save directly into a database or use further on or save it directly to state. So now that we've talked about all of that, we're going to put it all together and we're going to build a graph. So the first thing we're going to do is we're going to define our state, right? That's the first thing we should think of when we're building our graph. We want to implement our nodes. So the mental model I like to use when trying to design a flow is I like to think of a decision tree. So I start from the beginning and I think, what are all the possible decisions I would have to make, as well as if I do make this decision, where do I spawn off from there? And that gives me a good idea of what are all of the nodes that are needed for my system, as well as what should each node do. What should be the function of each node. So after we've implemented the nodes, we then now want to compose and connect everything. We want to define all of our edges, our conditional edges, as well as some of our dynamic edges. And then at the end, we just compile and invoke our graph. Now, I probably should have asked this question in the beginning, but just a raise of hand, like who here has heard of LangChain and LangGraph before? Okay. Okay, and who's used it, has built an application with it before? Okay, so yeah, this isn't anything new then. Oh, you said that? Oh, okay, that's cool. So first we're going to do is just define our state. So for this example, this is a pattern that I like to use where I like to split up all of my different states. When we create our graph, we have the option to set the overall state schema. We can define what our input schema should look like, as well as what our output schema should look like as well. So this is what I like to do. So we have a greeting where we're just replacing the previous value with the current value that we receive. And we're doing the same thing for this name field. So we define our state. Now we implement our nodes. So we're just going for a very basic structure. We're just going for a very basic structure where, the first node, it just updates the state for the name field. Second node, it takes that name and then updates the greeting field. Very, very basic system. No AI is being used in here at all. Just orchestration. And now we finally compose and connect everything. So here we would go and we would create our state. We would create our state graph. We define our state schema as well as our output schema. You don't need to define your output schema. I just use it just because I don't need everything returned to me at the end. So after that, we define our nodes. Now, one of the good things about LangChain is at compile time, it'll let us know if we have an unreachable node. So we can't just throw a node. So for example, if I were to add a node here, add nodes 3, but I don't define any of the edges, as well as when initializing the node, I can pass a third argument to specify all of the dynamic nodes that this node can end from. If I don't do that, like this code won't compile. It'll throw an error and tell me that there's an unreachable node and that I need to fix my graph in order to ensure that everything is connected. But assuming that we've built it and everything is connected, this would be our very basic graph. We start. This is the entry point for all of our graphs. This special key start. we know that from start, we need a direct edge from start to nodes 1. From there, we also need a direct edge from node 1 to node 2. And from there, we also need an edge from node 2 to the end. And this is the end of our graph, the end of our flow. So, after we've composed and connected everything, now we just compile it. So to compile it is relatively easy. We just call the compile function. And now that we've compiled this graph, we can now invoke it. So for here, if we were just to invoke it, because we don't have an input schema, we just pass an empty object. And we invoke the graph, it starts, it goes to node 1 executes, it goes to node 2 executes, and it goes to the end. And this pattern that you see here, this runnable sequence, like this is what a lot of LangChain applications are, where we just know that we have one function, we want to pipe its results to the next function, we want to pipe its results to the next function until we finally end. So there's also this wonderful utility method from LangGraph where we get to actually generate a mermaid graph of a mermaid image of our actual graph. And this is just to visualize it, rather than just looking at the code and trying to create a mental model of how everything connects together. So now we're going to talk about LangGraph Studio. Just as an example, has anyone used LangGraph Studio? Oh, okay. I love it. It's amazing. So LangGraph Studio is a web interface that the LangChain team has put together, and it allows us to have more of a deep dive into what is it that our agents are doing. So we can visualize each node within our graph and their edges. We can see the state as our agent is streaming its results. We can modify the state and create different forks. So for example, if you have a node that's meant to create a web search, and then you would take this web search and just call some API to fetch the results. As it's generating that web search, if, for example, you look at it and you think this web search could be better, instead of going through and modifying the prompt that actually generates that web search, you can actually create a fork directly from that graph where you modify the state and then tell the rest of the graph to continue execution from this new point. So it makes developing and just prototyping features much faster. So for the examples, I'll use the LangGraph Studio to show off these examples. And the best part is that it's framework agnostic. So it works out of the box if you're using LangChain. You just have to update your environment variables. But if you're using another framework for building your AI workflows or your agentic systems, you can still use, obviously you won't see this unless you're using a graph-based API. I don't know whether or not this works for Pydantic AI, but I do know their traces. Their traces are useful across multiple different frameworks. You just have to go through and import the Langsmith package and then go through the work of, adding all of the profilers and just making sure you hook up all of your code to send its data to Langsmith. So this is just an example trace of one of the projects that I built in the past. It's just meant to be a replica of Notebook LM, where there's a research agent that it has a list of topics that I find interesting. It generates our deep research for that topic, and then it spits that source material into a secondary agent, which will just compose a podcast episode 15 minutes long on that topic itself. And then it just uploads the audio to blob storage, saves the record into the database. And then I have my own UI that I use to just, it runs on a cron job. So like 8 a.m., I get a notification, new podcast episode. So this is deployed in the cloud. Obviously, I can write my own code to look into the logs of what's happening. But just by adding the Langsmith environment variables, I can just head right into the Langsmith Studio. And I can see like what is going on in each and every step of my LLM call. I can see how long it took. I can even track how many tokens it takes for each call. So this is very useful when it comes to debugging as well as just profiling some of the things that you're working on. So if you are building LLM applications and you don't want to use LangGraph, I mean, that's okay. But I would definitely check out Langsmith, and they're not the only provider that's working on building an observability platform on top of these LLM applications. I just really like it. It works. I just update my environment variable and poof, I have this. So now we're going to get into the fun parts. So I suffer from having way too many projects that I want to do, but just not enough time in the day. I'm way too ambitious for my own good. So I've always wanted a personal assistant to, in a sense, something that I guess the best way to explain it is if you've ever seen the episode of White Christmas in Black Mirror, what it was is a user took a snapshot of their consciousness, they put it into the smart device. The smart device had access to their home and it was responsible. And because it was a snapshot of the person, it knew how best to manage everything around the house. So I've always thought it would be very interesting to have something similar to that. Now, because I'm using LangGraph, I thought I can think of a decision tree around just scheduling events. And then I, went and decided to build this graph. So while I was building it, and I guess I didn't finish this slide. So I had a couple of constraints. One of them is I didn't want to have to be extremely verbose in the request that I make to the system. I just want to say, book me an appointment tomorrow to walk my dog. And the system should be intelligent enough to look at previous requests to think of, can I infer what this user is asking me to do? Or are there follow-up questions that I need to ask? I don't want to have to say at exactly 9 a.m. to 10:30 p.m. at this location, book an event for this title. At that point, I might as well just create the entry into my calendar myself. So we're going to just show off this example. What? Oh. There you go. So this was the example I was showing earlier, just some of the observability and the tracing that you have access to. This is, what is this? Oh yeah, this is the podcast agent that I was talking about. And I believe this run might have been from this morning. So I get to dive deeper into this to figure out, what's exactly going on. Like I made this call to OpenAI, like here I can see what my system message was. I can see what my follow-up human message, as well as the output that I got back from the system. And it gives me more insight into everything that's going on. But when I'm developing my application and when it comes to testing it, I can use the LangGraph Studio in order to develop my application. So this is just a POC, but this is just a small scheduling assistant that I built. We have a router. So once we enter this graph, we have a router. The router is just responsible for deciding whether to route to this gather requirements node or general. General will just try to answer the user's request based off of the previous chat history, and gather requirements is needed whenever we need to create, modify, or delete an event from the user schedule. So we gather requirements. We would then now want to, we generate a query. We define our edges between generating the query, going to is valid query. We define a conditional edge from is valid query based off if the query that the LLM generated is invalid, we would want to route back to generate query. In the event that it is valid, we want to route to confirm query. So within this schedule, we have 2 human in the loop flows. For gather requirements, if there are any follow-up questions that need to be asked, the system will interrupt the graph and it will wait for me to resume the graph with the answer to the follow-up question. As well as for confirm query, it will also create a confirmation message and interrupt the graph and wait for me to either confirm or deny whether or not the system should execute that query against the DB. And finally, we just summarize the results. So this was just a basic system I had in mind. I was able to use the low-level primitives and APIs that were provided from the LangGraph library in order just to compose a very simple AI workflow to represent an assistant who just schedules tasks for you. So we'll just test this out. Hopefully the demo gods bless me. So as here, when developing our application, we can actually track the. So when developing our application, we can actually track the flow of our graph as well as all of the individual nodes that we went to and which state updates that they all made. So we start with our query, our router decides that we need to head to gather requirements. When we head to this gather requirements node, there were no interrupts that needed to happen, as just explaining your schedule for the day doesn't really doesn't need any follow-up questions. So we just continue from there to generate a query where we generate the structured output, which is this, this query as well as the parameters. We check if it's valid. We use this human in the loop flow to interrupt our graph to ask for confirmation. Here, ooh. Okay, so here we can just say, yeah, that's fine. And then, so we just resume from here and we're able to just resume, we execute the query, and then boom, we now have a response where it tells me that I have a schedule to walk my dog tomorrow from 2 p.m. to 3:30. So that's cool. So this is an example of a system that you can build utilizing LangGraph. And now I will showcase. And then so we. Okay, so very basic scheduling system, a workflow we were able to build using LangGraph. And then this is the last system. So this is just an order entry voice agent. So I was in the Taco Bell drive-through line and I noticed that they have this AI agent that will take your orders. I thought that was pretty interesting. So I thought, okay, I can figure out what a decision tree for getting a user's order and creating a draft order would be. And then I can most likely put together a workflow that can solve that use case. Okay. So this is there's a lot going on here. Because of time constraints, I won't go into too much detail on exactly what's happening here, but this code is available on my GitHub. So if you want to play around with it, you can. But this just shows how you can use LangGraph in order to build out a very basic workflow. And for this one, its use case is for collecting orders at a fast food restaurant. So we're going to show how we can use configuration to modify our graph. I can create a new assistant here. Let me just call it Yum Brands. For here within our configuration state, because of the text-to-speech as well as the transcription model that I'm using, it's multilingual. So we can configure this graph to choose whatever source language we want to use. I speak English and a little bit of German, but to not embarrass myself, we're just going to do this demo in English. For time zone, and this is useful because we also, if you can see there, we have a flag which is meant to a flag which is meant to determine whether or not upsells are enabled within our system. So we can configure the graph to decide after a user has reviewed an order, do we want to bring them into an upsell flow? Time zone is very useful if there are certain upsells that are based off of like promotional periods. So maybe like happy hour during, the hours of like, I don't know, 5 to 7. So for this one, we won't set the upsell enabled, and then I'll just increase the recursion limit. So this is a voice-to-voice agent, as in, if you see here, we have this audio input as well as this audio output node, and this is responsible for just transcribing the input that you give to the system, as well as to, finally give you the review. So let me just demo this off really quick.
Welcome to Demo Store. How can I assist you today?
You guys hear that? Okay, so in the first note, we have our welcome. Oh, actually, let me cancel. I'll need to rerun from here.
Welcome to Demo Store. How can I assist you today?
Can I have 2 cheeseburgers and 1 onion rings?
Hello there. Let's go over your order. 2 cheeseburgers, $9.49 each. 1 onion rings, $4.49. Your total comes to $23.47. Does that all look correct, or would you like to make any changes?
Can I actually change it to 1 cheeseburger instead of 2?
Hello there. Let's go over your order. 1 cheeseburger, 1 onion rings. Your total comes to $13.98. Does that all look correct? Or would you like to make any changes?
I'm satisfied with this order. Thank you.
All right, your order for a cheeseburger and onion rings is confirmed. Thanks for choosing Demo Store. Your delicious meal will be ready shortly. Enjoy your meal and have a great day.
Okay. So yeah. So due to time constraints, I'm not going to go through some of the other paths of the system. If you notice here, we have this manual override node, which is meant to, if I say a ridiculous request, like I need 5,000 water bottles, is intelligent enough to know that that's not a reasonable request and that we should end the graph and go back to a human. So, and as well as there's some more flows into the modify ordered flow. But yeah, and we're not going to go over upsell. So yeah, this is just an example of the type of agents and workflows that you can build when utilizing the LangGraph framework. Okay, that's it.
All right. All right. So I'm going to be covering a couple things in particular. Number one, just out of curiosity, it's the talk of the town. Who's heard of MCP? Who knows what MCP is? Okay, the hands dropped. Okay. Which makes sense, right? A lot of people talking about it, they don't understand the use case of it or how it applies to them in a certain way, shape, or form. So let's kind of talk about the detail. Well, let me ask you this. Of the ones that said they know what MCP is, how many of y'all have built something with MCP servers? 1, 2, 3, 3 people out of the room. Okay, 4. I think I saw a hand. All right. We'll cover this a little bit, right? So number one, let me explain what MCP is, why it's a big deal, why people are kind of excited about it to a certain degree. I'm going to go ahead and give like a detailed explanation. And the way that I explain this, for it to make the most amount of sense to folks, or at least add some detail here. Hold on. Okay, let me pull this up. I just minimize this. No, okay. So the way that I explain MCP for people to understand it real quickly is it's a pattern, or not a pattern, but it's a way, it's an open standard for the models to get more context applied to it. So the example that I give is how many of y'all, like, anybody here live in like the Frisco area? Okay, a couple people. I live in Frisco. There's a restaurant I went into literally today with my wife. We usually, after we drop our kid off at school, it's me and my wife time. We go have breakfast together, talk, mess around, like, just talking about the day, what we're planning to do that day, kind of detail it out. And there's a restaurant that we like a lot, and the owner just changed. It was kind of a shock to us because we had no idea. We go there, maybe 2-3 times a week, give or take. And now, usually when we go in there, they kind of know what we want. We don't really have to say anything. It's usually one of the similar things. They're like, you want that today? Gotcha. I love that, right? And so today, it was like, oh, I have to actually explain what this is, and I forgot the name of the dish. So I had to look through the menu, looking for the dish. And so MCP, the way that you can kind of think about this in these terms, by the way, this is really happening. I didn't just make this for the talk. It literally happened this morning. And I was like, this is perfect for this. But the way MCP works is, without an MCP, every single time you're interacting with the LLM model through whatever service that you're using, it is as if you're interacting with it as a complete stranger. They don't know who you are. They have no context into what it is that you've done before this. They don't know how amazing, how great, how terrible that code may be that you're interacting with it. It is a brand new instance every single time, like my interaction with the waitress this morning. Or if you have an MCP server, it has all this additional context that you're applying with it, so it has a better understanding of what's happening here. Like my previous interactions going to the restaurant, where they would see me, they look me up in the system, they know exactly everything that there is to know about me, and they can get my order exactly the way I need to with very little prompting needed on my side. So this is the way that I kind of explain. Does that make sense? Perfect. So now going through this. So today I'm going to showcase, I had an idea. I was in San Francisco 2 weeks ago, and there I had officially crossed 100 days with Duolingo. Now, if you look at Duolingo in the media or whatever, they got some hate right now. That's neither here nor there. But I realized after 100 days, I didn't know anything in Spanish. And I was like, you know what? Something's got to give, right? And so I said, what if the learning style that they implement just doesn't work for me? What if I just come up with something that I can make on my own, where I'm like, oh, I'm going to go ahead and start learning Spanish, right? And so, bring my terminal up, I ended up creating my own MCP server for a Spanish language learning application. Let me see if I can zoom in on this. Now, obviously, this is all in my terminal for version 1, but I can interact with it. Why is it scrolling like that? Okay, let me just do this. Clear. Oh. Let's try this again. Oh, no, did I just break it? Well, let me scroll up to the demo that I had that I tested. I don't know what I just did. The way that it shows, it gives you 4 options in particular, right? Where it's like you can go vocabulary, you can go grammar, you can mix it up if you want to, you can exit, right? And so I said, let's go with vocabulary, and give me some useful phrases I can use to interact with my waiter at the restaurant. They're from Spanish background, right? So I was like, can I see the menu? It gives you the sentences, et cetera, right? Really cool, kind of implements it, gives me different scenarios where I could test it out. And then I could start talking back, giving it a sentence. It'll mock a conversation for me. That would have been really cool via terminal, by the way, just saying. But I said, this is really cool because I'm giving it this information. I'm prompting it, it's sending me something back, but I'm adding context every single time. And so it will keep I'm storing all this in the app, right? All the information as to like what this user is doing at this time. So over time, it keeps adding this context, and it will even often, I think it's every like 50 responses, it will re-audit the context to be like, does this user learn better via A, via B, via C, et cetera, and it will augment that so that way the model has better context as it continues, right? But then I said, you know what? I'm Danny Thompson. We got to make this a better demo. So what I did In the back, yeah, I did break it. I ain't gonna lie. But it's because I was focused on the other part of this demo, and I now know as I'm talking, I now know what I did wrong, which is good, I suppose, right? But let me refresh this visual demo first to make sure. Okay, cool. So I said the cool thing with the MCP server is I can attach any front end I want and have it working for me as like a mock backend for the LLM prompting and all that good stuff. So I actually created this visual demo here, and I kind of escalated this a lot. So as you can see here, this demo in particular, dang it, the image is not looking. Anyway, this demo in particular, we have 3 tiers, right? I figured it would be great if every user that's logging in, we can select their tier for them. Now, I put this on the front so that way you could see it, but in the back end, we could just toggle what tier it is. It's a free user, it's a basic tier, maybe they're paying like 99 cents a month or something, or a premium tier, maybe they're doing $9.99, right? So with those tiers, they get a couple additional items. Now, I really couldn't think of like what additional items I could put, so I decided to like create a rate limiter of how many prompts they can do within a given minute. The context size, I would reduce it so that way for a free tier, you're only going to get a couple items, but if you add additional tiers, you can get way more. And basic features only. So we'll do this example here. I should just mock this thing in the front, actually. Hold on, this is not going to be fun to do this way. Hold on. I don't like the way this is working. Let me mirror my displays. If it'll show. And we will now mirror it. Perfect. Yeah, I didn't like the way that I kept looking back and forth, but it's still showing that. There we go. Oh. What in the world? Extend, mirror. Hey, okay. I am a developer. All right. So with this, we can kind of go through our query. So here I put the query as like, how do you say hello in Spanish? That's default, but we can put anything that we want in there. And so we can see via our system logs, we're sending something in. Right now, because I'm only using the main API key that's already set in the server. For this demo, I didn't put a second API key. So we're getting one response there for that 404. But you can see here, we have our Spanish greetings. Here's some common ways to say hello. Hola, buenos dias, buenas tardes, etc. We have our user tier limits, and we have our rate limit. So if I do the same request again, we'll see it one more time, and then we'll do it one more time. We now have our rate limit exceeded. So it's keeping track of that rate limiting, and after 60 seconds, it'll reset itself. But now if I were to switch it to like a basic tier, for example, and prompt it again, we have way more responses this time, and things like that. Somebody give me a sentence that we could translate from English to Spanish. How do I not break my demo? This is a simulated response. To see the different responses, that's not right. Well, kudos. All right. And then we could do premium tier. It's same thing. It should be, or let me see. Let me stop this one. Oh, definitely not the push. NPM start. That might be it. And then how do I not? Nah, I don't know what's going on. I got to figure that out. Regardless, imagine it worked great and this was phenomenal. That's what I'm talking about. So yes, via that, that's essentially the way that we could attach any kind of tiers to that or anything like that. So let's kind of just jump through some of this code real fast. And so you can kind of see here, we have our MCP for Claude. And so we have some of the, I'm using Anthropic's Claude. I'm a big fan of Anthropic as a whole. You could use whatever you want. You're just wrong. But with this, we have some information that we're going through. So we're providing a lot of this context. We're customizing the prompt that we want to see come out, but we want to make sure that if we're going through the vocabulary tier, like that case is there for like the way that we want to display and showcase it, et cetera, et cetera. We can go through our async handler here. No, sorry, not async, our rate limiting. And so you can see here, the window for all of the requests on the free tier, you have a max of like 15 minutes. And so that default window of 15 minutes is there. But as you move your tiers, that will adjust accordingly. And then from here, you can see like create tiered rate limiter, and you can kind of see like too many requests, try again. We're displaying our errors. I was thinking to use like an error boundary instead, but I decided to go with this instead. And then we have authentication. We're doing it all via AppWrite. I'm a big fan of AppWrite. If you've ever utilized them, they've sponsored our meetups for like a year and a half now, minus as of late. So they're going to be sponsoring again soon. So I think that's there. Then we have our routes. So you can kind of see via our conversations. You can start the conversation. We have our topic. We have our difficulty level. As of right now for the demo, I put everything at a beginner level, but it only worked for one sentence. Participant count, include slang. So if you're at the premium tier, it would prompt you if you want to add slang vernacular or more common terms as opposed to just being everything proper. Because I feel like, especially if you're going to like another country, that's a great way to kind of familiarize yourself with how people talk. And the context sizing, of course. And I'm using JOI for the library. Some people call it Joy. Either one works. And middleware, the middleware is essentially just this auth that we're going through. Whoops. This auth that we're going through here. And so we have our API keys. And essentially the way this thing originally worked, at least the idea that I had, which I realized wasn't a great idea at the time, was you would get a separate API key from Anthropic, right? So Anthropic will give you the free tier with like no credits on there or something like that. And you could use that for the basic level of prompting. But then I realized like, I won't really get everything that I want out of that, like rate limiting and things of that nature. So I decided to swap it to, you only need one API key, and then we can just choose your tiering based off of that. So some of that logic is still kind of here based off of that. Like the required tier that no longer necessarily needs to be there the way that it was. And registering the user. So you could theoretically have a registered user scenario where they could log in and things like that. And I use AppWrite for that logging in featuring. Because honestly, they're auth. Not to like blow them up or like oversell them, but it takes like 60 seconds to put their auth in the app. And so it's like one of the easiest ways that I've ever seen, and very secure. So kind of just go nuts. Might as well save your time for everything else besides that, right? And so essentially, that's the way that I would utilize the MCP for a solution. I try to give like a real world example, but you can add so much more context into what it is that you're doing. I do have this on GitHub, but I'm going to be honest, now that I know something's broken, probably needs to be fixed. Outside of that, I didn't want to go too long. I know we spent way more time than usual on this. So I think we have the room for 30 more minutes, and that's it. So one thing that we do at the end of every meetup, I invite you to do this, please. We do a very large group picture together. So everyone, I invite you to come to the front as long as you feel comfortable. We'd love to grab one group picture with everybody, and then we'll call it a day.